Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick until the end of the video, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 4 to the power of x plus 4 to the power of x plus 3 is equal to 1/3. Now, for this equation, I obviously want to find the value of x. So for my solution here, first start with 4 to the power of x plus 4 to the power of x plus 3 is equal to 1/3. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 4 to the power of x plus 3, we can rewrite as 4 to the power of x times 4 to the power of 3. Now this is equal to 1/3. Now from here, what I'm going to do is I'm going to factor out 4 to the power of x. So now I have 4 to the power of x times, well, 4 to the power of x divided by 4 to the power of x is 1. So I have 4 to the power of x times 1 plus, now 4 to the power of x times 4 to the power of 3 divided by 4 to the power of x, simply just 4 to the power of 3. Now this is equal to 1/3. Now 4 to the power of 3, let's go ahead and find the value of that. Well, 4 to the power of 1, this is equal to 4. And 4 to the power of 2, this is equal to 4 times 4, which is 16. So 4 to the power of 3, this is going to equal 16 times 4, which is 64. So now I have 4 to the power of x times 1 plus 64 is equal to 1/3. Now 1 plus 64, that's equal to 65. So now I have 4 to the power of x times 65 is equal to 1/3. Now I want to isolate x, so I'm going to be dividing both sides by 65. So then these two cancel out. I'm left with 4 to the power of x is equal to 1/3 divided by 65, which is 2. Now, 4 here, this is the same thing as 2 squared. So if I replace 4 with 2 squared, I get 2 squared to the power of x is equal to 2. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of x, that's going to equal 2 to the power of 2 times x, which is equal to 2 to the power of 2x. So I have 2 to the power of 2x is equal to 2. Now 2 here, this is the same thing as 2 to the power of 1. If I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, 2x is equal to 1. Now if I divide both sides by 2, I get x is equal to 1/2. So this is my answer. Now, to go ahead and check, I'm going to plug in 1/2 into my original equation. So I had 4 to the power of x plus 4 to the power of x plus 3 is equal to 1/3. Now I know that x is equal to 1/2, so now I have 4 to the power of 1/2 plus 4 to the power of 1/2 plus 3 is equal to 1/3. Now, 4 to the power of 1/2 plus 3, well, 1/2 plus 3, 2 times 1 is 2, 1 plus 1 is 1, plus 2 times 3 is 6, so I have 1 plus 6, which is 7, so I have 7 over 2. So I have 4 to the power of 1/2 plus 4 to the power of 7 over 2 is equal to 1/3. Now 4 to the power of 1/2, this is the same thing as the square root of 4, which is actually equal to 2. So I have 2 plus, now 4 to the power of 7 over 2, this is the same thing as the square root of 4 to the power of 7. And the square root of 4 to the power of 7, that's going to equal 128. So I have 2 plus 128 is equal to 1/3. Now 2 plus 128 is 130, so I have 130, which is equal to 130, meaning our solution is right. I have 7 to the power of x is equal to 70. So I obviously want to find the value of x. So for my solution here, first start with 7 to the power of x is equal to 70, and now I'm going to take the log on both sides. So now I have log 7 to the power of x is equal to log 70. Now, an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this is actually going to equal b times log a. And this property is actually really important because this changes an exponent into an actual term. And look at this problem. Right now, x is an exponent, and it's really hard to solve for x because x is going to be a decimal. 7 to the power of 1, this is equal to 7. 7 to the power of 2, this is equal to 49. And 7 to the power of 3, this is going to equal 49 times 7, which is, I'll do it right here. 9 times 7 is 63, 7 times 4 is 28, and 28 times 6 is 34. So I have 343. So as you can see, the value of x is going to be somewhere in between 2 and 3 because it's going to be in between 49 and 343. So this property is really useful because now once we change x to an actual term, it's going to be much simpler to solve for. Alright, so now going back to the problem, log 7 to the power of x is equal to log 7. Now I can go ahead and move x into the front, so now I have x times log 7 is equal to log 7. Now I'm going to divide both sides by log 7. So then these two cancel out, and I'm left with x is equal to log 70 over log 7. Now log 70 we can rewrite as log 7 times 10. Now I have this over log 7. And if I have something in the form log a times b, this is the same thing as log a plus log b. So log 7 times 10, this is going to equal log 7 plus log 10. And I have this over log 7. Now the value of log 10 is simply equal to 1. So now I have log 7 plus 1 over log 7. Now this can simply be written as log 7 over log 7 plus 1 over log 7. And log 7 over log 7, these two cancel out. So I'm left with x is equal to 1 plus 1 over log 7. Now, to get the value of log 7, you can actually use a calculator. So log 7, this is equal to approximately 0.845. So now, 1 divided by 0.845, that is going to equal 1.183. So now 1 plus 1.183 is equal to 2.183, so x is equal to 2.183. This is my answer.